All right, y'all, let's get ready to have some fun with some perfect square trinomials and difference of squares. I like this one. It's going to be fun, y'all. Let's get going. All right, y'all, let's jump right into it, right? We ain't going to prolong the time. We're just going to keep it moving here. So check it out, y'all. Let's get going with this idea of perfect squares. So let's remind ourselves, right? Remember perfect squares. And I'll put a bunch at the top. Perfect squares are numbers we can multiply by times themselves to get, that result. So 1 times 1 is 1, 2 times 2, right? So we think of our perfect squares as 1 and 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, right? Et cetera, et cetera. You got it. Perfect squares. Now, when it comes to factoring certain, right? Just certain trinomials, take a look at this one. And look at that first and third term. Look at that first term. Look at that third term. They're perfect squares. So there are trinomials where you have to take your time and think about the factors. You're really going to think about the placement of them. And then there are some unique ones where you can do the factoring the same way you've been doing it. And because some of them contain some unique properties, we are able to jump right to the factored form, right? From our standard form into our factored form because of their unique properties. What are the factors of 4? 2 and 2. What are the factors of 9? 3 and 3. So 2 and 3. 2a plus 3, 2a plus 3. Or, right, in the factored form, this is suitable as well. Now, because this trinomial contains perfect squares, 2 perfect squares, that's why we're able to do this. Let's try another. Take a look at the terms. Again, take a look at that first one and that third one. And let's see if you're able to come to right here, if you're able to come down to the factor form just by looking at it. And you should have noticed, right, the factors for 9 are 3 and 3. The factors for 25 are 5 and 5. So that makes, right, don't forget your x, 3x plus 5. Excuse me. This is going to be 3x minus 5 squared. Because, friends, right, look at this middle term. Negative times negative will give me positive. But this is where I should be at. Be careful on your sign choices, friends. Okay, let's run another one. Actually, let me erase these. Right. Now let's go with this. Again, paying attention to signs. Looking at that first term, looking at that third term. What's happening here, right? Let's pay attention to that. 4 and 7. I think y'all got it, right? And because you see this middle term is negative, that makes this term negative here as well. Now, really quick, we know this to be written, right, where both of the binomials have the same sign, right? Now, what would happen if one of these signs were switched? So for example, excuse me there, friends, let's say I had a binomial that looked like this. Now, before, let me erase that. Before, we were looking at this, right, squared, and we know this to be x plus 5 times x plus 5, which, if you evaluate, friends, will give you x squared plus 5x plus 5x plus 25, which gives you x squared plus 10x plus 25. This, though, x plus 5 times x minus 5, where you have the same terms but different signs, comes out to be a little different, right? You still get the x squared, but you get a minus 5x plus 5x plus 25, minus 25. And if you reduce that, you get x squared minus 25. Notice what you're seeing here. Notice the connection here, and notice the connection with the problems. Now, this, friends, is called difference of two squares. Why is it two squares? Look at that answer we were working with. That's a squared. And believe it or not, this is squared too. What's 25 as if I wrote it as with a base of 5? Well, that's 5 squared. So if I were to rewrite this, that's x squared minus 5 squared. Do you agree with that? You agree with that equivalency? So if you do, right, difference of two squares. But we don't leave it like this. We just leave the answer like this. So looking at this connection, if I asked you to factor, to put in a factor form, something that looks like this into something like this, could you do it? If I asked you, okay, friends, factor this. X squared minus 36. What does that factor into? If you said x plus 6, x minus 6. Remember, friends, if you see me get to a problem that you want to try, pause the video. Don't forget to pause the video. You try it yourself. It's great to practice right along with me. Let's try another one. Y squared minus 144. What you get? Oop, not x. Y, not x. Y minus 12. Y plus 12. No, this order doesn't matter. If you put y plus 12 first and then you put y minus 12 second, doesn't matter. This is multiplication, so they're interchangeable. It's totally fine. Let's do a couple more. All right, x squared minus 64. X plus 8, x minus 8. Now let me pause real quick before we finish our last one. Look, y'all, note, this is not a thing. You can't do it. There's no arrangement of x plus 8 and x minus 8. Like, if we know that x plus 8 times x plus 8, it's going to give you a middle term. It's not going to give you this. This is not factorable. This is prime. This, if you see something where there's an x squared plus a perfect square, you can't do it, right? Because that's why this whole thing is called the difference of two squares. So if you see some addition like this, already understand, for the most part, it's factored. It's prime, right? Don't forget that. Now, I want to come to my last one here. Now, you're looking at this like, what is this, Mr. Bertrand? This one is way too easy. Yeah, because it sneaks up on people, right? This x squared minus 1. And people forget that we at least in the previous units, we really weren't using the perfect square of 1. It wasn't really getting us anywhere. But understand, you're going to see this a lot. And if you were to factor this, you get x plus 1 times x minus 1. I bring this one up because it is the silent destroyer of assessments, meaning folks will factor to a level and they'll see this and they'll leave it. Be careful of x squared minus 1. It shows up a lot. All right, so that's it. That's how we do it. That's how we're going to go into it. We jumped straight into it today, y'all. No pretense. We worked on perfect square trinomials and the difference of squares. Take a look at homework 21. Give it a shot. If you have any questions, of course, please let me know. And until then, y'all, be well. Take care.